Question: among electric field, magnetic field, angular momentum and vector potential, which is bar are odd under parity space inversion operation? For solving this, first we will take the electric field. We know that electric field E is equal to F divided by Q, and F can be written as M into dV by dt. Divided by Q is missing. Now we go for space inversion. So if we do for velocity, it will become minus of V. So if V become minus of V, then F will also be minus of F. So if F is minus of F, then the electric field must also be a minus of F. Therefore, it is a odd under parity space inversion operation. Now we can check the options. So E is odd under parity space inversion. So this option is incorrect. Either answer is option A, B or C. We have to check for another one. So now we check for the potential. Electric field in terms of a vector potential is E is equal to minus of del psi minus dou A by dou T. So here we know that already E is odd. So then A must also be, that is a vector potential must also be odd under parity space inversion. So therefore E vector and A vector are the odd under parity transformation. So answer is option B. Question: the expression for the second overtone frequency in the vibrational absorption spectra of a diatomic molecule in terms of harmonic frequency and anharmonic constant is. So in this question they have asked us to find what is the second overtone frequency. So in case of vibrational spectroscopy, the vibrational energy in terms of wave number is given by E is equal to n plus half omega E minus n plus half the whole square omega E xc. Now the question they have asked us to find for second overtone. So for second overtone, the transition is from 0 to 3. So energy difference between the third state minus the first state is delta E. So this corresponds to the substitution of n value 3 here. So substitute n value 3 and you will be getting this. And for this one, substitute n value is equal to 0. Here 0 will come. So then you will be getting this expression. By simplifying it, we will be getting 3 omega e minus 12 xc omega e. 3 omega e can be taken as a common term. So you will be getting 3 omega e 1 minus 4 xc. Now if you see the option, answer is option D. Question: for nucleus 164 rpm, a J pi is equal to 2 plus state is at 90 kilo electron volt. Assuming 164 rpm to be a rigid rotator, the energy of its 4 plus state is dash in kilo electron volt. So we have to find what is the energy of 4 plus state for rpm and assuming it as a rigid rotator. They have provided the what is the energy of 2 plus state, that is 90 kilo electron volt. For rigid rotator, the rotational energy is given by Ej is equal to Bj into j plus 1. Here B is the rotational constant. From the given data, we have to find what is the value of B and then we will be finding the energy of 4 plus state. So in the question, they have given J is equal to 2 and the corresponding energy is 90 kilo electron volt. Now substitute the value of J and E in this expression and we can find the B value as 15 kilo electron volt. Now after this we know the value of B. In the question they have asked us to find for 4 plus state, that is J value is equal to 4. So J is equal, for J is equal to 4, E of 4 is equal to 300 kilo electron volt. Question: three particles are to be distributed in four non-degenerate energy levels. The possible number of ways of distribution, option 1 for distinguishable particles and for 2 for identical bosons respectively is. So in this question they have given a 3 particles and also a 4 non-degenerate energy levels. They have asked us to find what is the possible number of ways of distribution if we consider the particles as a distinguishable particle for option 1, and for 2 if we consider them as an identical boson. Ni is equal to number of particles is 3 and Gi number of energy levels is 4. So first we will consider the distinguishable particle. So the number of possible ways is equal to Gi the whole power Ni. That will be 4 power 3. That is 64. Now you consider it for the identical bosons. So possible ways of distribution is equal to Gi plus Ni minus 1 the whole factorial divided by Gi minus 1 factorial into Ni factorial. That is 4 plus 3 minus 1 factorial divided by 4 minus 1 factorial into 3 factorial. This is nothing but 20. Therefore, answer is option C. Question. A microcanonical ensemble consists of 12 atoms with each taking energy 0 state or energy E state. Both the states are non-degenerate. If the total energy of this ensemble is 4E, its entropy will be dash in Kb, where Kb is the Boltzmann constant. In this question, they have taken a microcanonical ensemble and it consists of 12 atoms, and they have taken the energy levels of 0 state and also the E state, and also they have said that the states are non-degenerate, and the total energy of the state is given as 4E, and they have asked us to find what is the entropy of the system in terms of Kb. We know the formula entropy S is equal to Kb into ln of omega. That is, this is number of possible microstates. We have to find the value of this. They have given, and it is given N is equal to 12, and also the total energy as 4E. So the omega is nothing but the number of combinations in which it can be arranged. That is NCR is equal to n factorial divided by r factorial into n minus r factorial. That is 12C4 is equal to 12 factorial divided by 4 factorial into 12 minus 4 factorial. That is 12 factorial divided by 4 factorial into 8 factorial. It is nothing but 495. So entropy S is equal to Kb into ln of 495. That is nothing but 6.2 into Kb. So answer is 6.2. Question. An air conditioner maintains the room temperature at 27 degrees Celsius while the outside temperature is 47 degrees Celsius. The heat conducted through the walls of the room from outside to inside due to temperature difference is 7000 watt. The minimum work done by the compressor of the air conditioner per unit is dash in watt. So in this question is basically from thermodynamics, and they have asked us to find what is the minimum work done by the compressor. So we know that for a air conditioner system the coefficient of performance Cp is equal to Q divided by work done. So here they have asked us to find what is work done. So work done is equal to Q divided by Cp. So in the question they have already given the value of Q, that is 7000 watt. That is heat extracted, divided by Cp is given by the formula Tc divided by Th minus Tc. In the question, they have given the values of Tc as 27 degrees Celsius. When we convert it into Kelvin, 273 plus 27 gives 300 Kelvin. The hot temperature Th is 47 degrees Celsius. So again it is converted into Kelvin. We will be getting 320 Kelvin. So now substitute the values. That is 7,000 divided by 300 divided by 3 300 320 minus 300. So now when you simplify this, you will be getting work done as 466.66 watt. So the answer is 466.66 watt. Question: the partition function of an ensemble at a temperature T is Z is equal to 2 cos h E divided by kBT the whole power n. Where Kb is the Boltzmann constant, the heat capacity of this ensemble at T is equal to E divided by Kb is x into n Kb, where the value of x is dash. So in the question, they have given a partition function and they have asked us to find what is the heat capacity at the temperature T is equal to E divided by Kb. So the heat capacity of the ensemble is given by the formula Cv is equal to dou U divided by dou T at constant V. So we need to find what is the value of U. So U is equal to minus of dou by dou beta ln of Z, and Z is nothing but the partition function. Now substitute the value of Z in U. So you will be getting U is equal to minus dou by dou beta ln 2 cos He divided by kBt the whole power n. Now instead of kb, we know that beta is equal to 1 divided by kBt. So instead of 1 divided by kBt, substitute beta. So you will be getting E into beta here. Now differentiate ln with respect to beta. So you will be getting 1 divided by 2 cos He beta. Now we have to differentiate this term alone. So for cos, we will be getting 2 is a constant, so keep it as it is, and for cos we will be getting sin He beta into E. Now sin divided by cos is nothing but tan. So by simplifying the U, we will be getting minus Ne tan He beta. Now we have found what is the value of U. Now substitute it here and find the derivative with respect to T at constant volume to find the value of heat capacity. So Cv is equal to dou by dou T into minus Ne tan He divided by kBt. So now if you differentiate this term with respect to T, you will be getting minus Ne is a constant, and then for tan we will be getting secant square E divided by kBt, and for E divided by kBt it will be minus 1 E divided by kBt square. So Cv will be N E square divided by kb t square 1 minus tan h square E divided by kbt. In the question, they have already asked us to find what is the value of Cv at T is equal to E divided by kb. So at this T, the value will be, substitute for T, E divided by kb. So we will be getting N E square kb into E divided by kb square minus tan h square E divided by kb E divided by kb. So by simplifying this, we will be getting N kb into 1 minus tan h square of 1. So the value of tan h square of 1 is 0.579. So by simplifying it, we will be getting N kb into 0.421. So in the question, they have already given Cv is equal to x into N kb. Now by comparing these two, we can write the value of x is 0.421. In the description box, you can find solution for GATE Physics 2020 and 2019 question papers. Please share and subscribe the channel. If you have any queries, write in the comment section.